Today what we're going to do is we're going to look at the properties of all those quadrilaterals that you've been measuring for the last 2 days. Okay, so I'm going to kind of put it all together for you and maybe make some connections as to why things happen the way that they did. So the first shape we're going to look at is just a trapezoid. Before we go any further, you have 2 papers there. You have like that quadrilateral family tree that we've drawn out before, and then you have some practice problems. So I'm going to be flipping back and forth between the 2. All right, so the first shape here is a trapezoid. And by definition, a trapezoid is a quadrilateral with exactly one set of parallel sides. Okay, so there's our parallel sides. Now, one connection we can make here is that in chapter 2, we talked about parallel lines and transversals, and we talked about how between the parallel lines there, those are called same side interior or consecutive interiors, and we talked about how those are supplementary. So for instance, angles 1 and 2 here would be supplementary. Angle 3 and 4 would be supplementary. Okay, so angle 1 plus angle 2 would equal 180. Same thing with angles 3 and 4. And that's really all that you really need to know about trapezoids at this point. Okay, so we have a more specific type of trapezoid called an isosceles trapezoid. Now, again, because it is a trapezoid, it still holds those key properties, right? We still have our parallel lines, and we still know the angles between the bases are supplementary. Okay, so now, when you deal with isosceles trapezoids, you get a little bit more terminology that comes in here. So the parallel sides are referred to as the bases. So there's one base here, and then there's another base up here. There's another base right there. Okay, then an isosceles trapezoid actually has 2 congruent legs. So those are referred to as legs. All right, so some properties that happen on our isosceles trapezoids. Okay, so one thing that happens is that along the base you have what are called base angles, and our base angles are congruent. So we have a set of congruent base angles there and here. Okay, so we have 2 sets of base angles that are congruent. Now these, we're going to prove this, I think on the Wednesday when we come back from break. We're going to break this down and prove why this happens. Okay, so just, you just have to believe me for a little bit here. All right, so now let's talk about the diagonals. So I'm going to draw in my diagonals here. Here's one diagonal and here's another diagonal. All right, so what happens is the diagonals, we're going to look at 2 triangles that are created with those diagonals. So here's one triangle right here, and here's the other triangle. All right, so I'm going to draw these out separate. Okay, so we have the green one on the left that kind of sits like this, right? I have that marked as being congruent, and we have this angle marked as being congruent. Okay, and then we have that yellow triangle that sits more like this. We have this angle marked with 1 tick mark, and I have that side marked with 1 tick mark. Now notice they share that base. They share this piece right here. So these 2 triangles are congruent by side angle side, which then means by CPCTC that these parts are congruent. That happens to be our diagonals. Okay, so the diagonals of an isosceles trapezoid are congruent. Okay, so now what I'd like you to do is take a look at these 2 problems. So I would pause the video, then do those problems, and then when you're ready, hit play again. All right, so let's take a look at this one here. So we know that the angles between the bases of a trapezoid are supplementary. Okay, so if we have our given of 55 degrees, right? So this A up here is going to be 180 minus 55, or 125 degrees. Angle C is a base angle with 55, so I know this has to be 55 as well, and angle B there has to be 125. All right, so A was 125, B is 125, C is 55. As far as the sides go, those are 2 congruent legs in an isosceles trapezoid. So that's 3x minus 3 would have to be equal to, or equivalent to, x plus 5. So I can subtract an x from both sides, I have 2x. Add 3 to both sides, I have 8. Divide by 2, we get x equals 4. All right, for the example on the right, again, we know that this angle here and this angle here are angles between the bases, so they have to be supplementary. That means that 6x plus 20 plus 4x should equal 180. So that means 10x plus 20 equals 180. Subtract 20 from both sides, I have 10x equals 160, which means x equals 16. Okay, so now we can plug this back in. 6 times 16 plus 20 will give me 116 degrees. And we know that these two base angles here have to be congruent, which makes y 116 degrees. All right, now we're going to talk about the kites. Okay, so a couple of things first before we get started. When you have a kite, there's a little bit of terminology here. Well, first of all, a kite, we know, is a quadrilateral with two sets of distinct consecutive congruent sides. Okay, so a connection I want to make with you, if I were to draw in this diagonal, if I ignore the bottom half, okay, so if I ignore this part right here, okay, that top shape is actually an isosceles triangle. Okay, so let's remove that. Okay, again, I'm going to put my diagonal back here. If I were to ignore the top part, that bottom shape is an isosceles triangle. So really, a kite is just two isosceles triangles that share a base. Okay, now that being said, when we talked about isosceles triangles, we said the angle between the congruent legs is called the vertex angles. So on a kite, the angles between the congruent sides are called vertex angles. The other two angles, so we're talking about these two here, these are called the non-vertex angles. Very creative, I know. These are the non-vertex angles. All right, so there's a little bit of terminology. All right, so first thing I want to do here is I'm going to go ahead and draw in one of my diagonals. So let's, oops, I kind of missed there. See if I can fix that. All right, so here is one of my diagonals. All right, if I were to draw that in, again, keeping in mind that because it's a kite, we have two sets, two distinct pairs of consecutive congruent sides. I can actually prove the triangle on the left congruent to the triangle on the right because they share that diagonal, right? So by side, the triangle on the left is congruent to the triangle on the right, right? This one is going to be congruent to this one. So what that means for us then is that we have a whole lot of congruent angles now. Okay, so I know these two angles are congruent because of CP/CTC. These two angles are congruent because of CP/CTC. And these two are congruent because of CP/CTC. So the diagonal that connects the vertex angle, so back to that vertex angle idea, excuse me, the vertex angle idea, that diagonal bisects the vertex angles. We also now know that the non-vertex angles are congruent. Okay, let's draw in the next diagonal now. Let's see, where's my tool? There we go. So if I draw in the other diagonal, oh, let me see if I can change that color because that's hard to see. There we go. Okay, so if I draw in that next diagonal, I want you to again focus on the top. Okay, focus on the top triangle there. So keep in mind, we just talked about how that triangle, this triangle right here, is isosceles. Okay, think back to when we did isosceles triangles. We said if you bisected the vertex angle, that angle bisector then was also the altitude and the median to the base. Okay, so it's all coming back to those isosceles triangles there. So now we know on a kite, we know that the diagonals are perpendicular. right? And then the diagonal that goes from vertex to vertex bisects the other diagonal, right? It breaks it in half. All right, so there's a lot of properties that happen with a kite, but it's super important that if you can just understand that they come from isosceles triangles and you remember your properties of your isosceles triangles, then you don't have to memorize all the properties of a kite. You can just understand what's happening and draw those conclusions that because you have a bisected angle, then you have an altitude and you also have a median. All right, so again, do the problems for the kite, and then you can unpause the video. So start these problems, and then you can, when you're ready, unpause the video, and then I'll go over them with you. All right, so for the first one here, I have to recognize that these are my non-vertex angles, and those are the angles that are congruent. So I know this has to be 116 degrees. So if I start with 360, take away 116, 116, and 82, I'm left with 46 for x. On the next one, keeping in mind that AE is my diagonal, right? That's bisecting my vertex angles. I know this has to be 29. Then I have a right triangle right here. So I can solve for this missing angle x here. So I take 90 minus, well, 180 minus 90 minus 29 will give me 61 degrees. So x is 61 degrees. Okay, now I have some expressions here. It says CB is 3y plus 6, and BD is 8y minus 9. And I give you that AB here is 7y minus 1, but that's really just a distractor. You don't need that at all. So I do know, though, that my diagonal here has been bisected, right? So these two have to be congruent, which means that 3y plus 6 has to be equal to 8y minus 9. Okay, so if I subtract 3y from both sides, I have 5y. Add 9 to both sides, I have 15. Divide by 5, I get y is equal to 3. Okay, let's look at our parallelograms next. All right, so a parallelogram, by definition, is a quadrilateral with two sets of parallel sides. Okay, we have one set here, and we have another set here. All right, so now, when you came into geometry, you knew more about parallelograms than I really want you to know. But you came in and you told me parallelograms, opposite sides are congruent. And you're absolutely right. But that's not really what makes a parallelogram a parallelogram. And if you remember, I told you you knew it just enough to be dangerous. Okay, so what we're going to do today is figure out why the opposite sides are congruent. So this is the connections I'm talking about. All right, so what I'd like to do is draw in one set of diagonals. So I'm going to draw in this diagonal here. I don't know why I keep getting that shadow. Okay, so I drew in that diagonal. So what I'm going to do is I'm going to prove that this top triangle here is congruent to this bottom triangle here. And you'll see why in a second. So let's think about, if we talk about these two lines being parallel, this is my transversal. I have one set of alternate interior angles here. And then I also have another set of parallel lines here and here with my transversal. So I actually have two sets of alternate interior angles, right? So these two have to be congruent. And then those two triangles share this diagonal. So by angle, side, angle, my two triangles are congruent. Which means then by CP/CTC that the opposite sides have to be congruent, right? Right. The corresponding parts of my triangle are congruent. It also means that opposite angles have to be congruent. All right, so I'm going to erase this part here. Well, maybe it won't let me erase it. Oh. There we go. Okay, so we now know that why opposite sides of a parallelogram are congruent. We now know why opposite angles of a parallelogram are congruent. Okay, so a little side note over here. we know that opposite sides have to be congruent and opposite angles have to be congruent. Okay, but that's not all. It's like an infomercial here. So that's not all that happens with parallelograms. Let me draw in another diagonal here. All right, so, oops, uh-oh, I don't know what I did there. Undo. Okay, so this diagonal, okay, if I draw that in, I now have a new transversal. Okay, so this is a new transversal, but again, I have those same parallel lines. So keep in mind, this angle here, so I think I need 4 tick marks, is going to be congruent to this angle here because they're alternate interior angles. Okay, now we can focus specifically on 2 triangles. That's all we really need to do. What if we focus on these 2 triangles right here? Okay, so I know there's a lot of markings on here, but what you'll notice is we have a red 1 tick, a red 1 tick, and then a green with 3 ticks and a green with 3 ticks, okay? So we have 2 sets of angles that are congruent, and then the sides that are congruent. So by angle, side, angle, this yellow triangle is congruent to this green triangle. Okay, so now, because of CPCTC, the corresponding parts have to be congruent as well. So that means that those 2 sides have to be congruent and those 2 sides have to be congruent. So what ended up happening was the diagonals end up bisecting each other. Okay, so the diagonals cut each other in half. All right, so 3 big takeaways from our parallelograms. Opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. All right, so same routine. Pause the video, try those problems on the next, and then start the video again when you're ready. All right, so we're going to go over these problems. We know opposite sides have to be congruent. So I just labeled my figure. So JK up there has to be 53, and KL has to be 38. We also, for the next one, we learned that the diagonals are bisected. So if QT is 13, then TS must also be 13. Then for the bottom problem, we know that opposite angles are congruent. So that means that 11x plus 2 has to be equal to 14x minus 10. I can subtract 11x from both sides. I get 3x. Add 10 to both sides. I get 12. That means x is equal to 4. All right, so our next figures that we're going to look at, the rhombus, the rectangle, and the square, those are all parallelograms, right? They're special parallelograms. So we have to keep in mind all of these next 3 figures are still going to have opposite sides that are congruent, opposite angles that are congruent, and diagonals that are bisected. But they're also going to have extra properties. Okay, so just kind of keep that stuff in the back of your head. So let's talk about our rhombus first. So by definition, a rhombus is a parallelogram with 4 congruent sides. All right, so I have 4 congruent sides here. So now, some special things that happen with our rhombus. I'm going to go ahead again and draw in a single diagonal. Okay, so here is a diagonal. Oops. All right, I gotta turn it the right color here. Oh, there we go. Okay, so I have my single diagonal drawn in here. So I want to think about the 2 triangles that I can see. There's one on top, one towards the bottom. So keep in mind, because we have congruent sides, 4 congruent sides here, this actually is an isosceles triangle. This is an isosceles triangle. Okay, now, we are going to prove that they're congruent in a second, but keep in mind, because it's an isosceles triangle, these 2 base angles have to be congruent because base angles of an isosceles triangle are congruent, right? Okay, so keep that in the back of your head for a second. Now, I can prove the 2 triangles congruent because they share this 3rd side. So by side, 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 this top triangle has to be congruent to the bottom triangle. If that's the case, then by CPCTC, the corresponding angles have to be congruent, which means then that actually all 4 of those angles are the exact same measure. What this means for us is that the diagonals bisect the angles. Hey, the same is true for the other diagonal. If I were to draw in, oops, let me get the right color here. If I were to draw in the other diagonal, hey, there it is. It is also going to bisect those angles. All right, so the diagonals of a rhombus bisect the angles. Okay, but wait, there's more, right? Okay, so go back to thinking about any one of those isosceles triangles. So let's focus on this isosceles triangle here. Remember what we talked about with a kite? We have an angle bisector going through a vertex angle here, right? So remember that angle bisector then is also the altitude, right? Remember how we talked about that? And then we still, because it's a parallelogram, we still have diagonals that bisect each other. Okay, so it's a parallelogram, so opposite sides, opposite angles are congruent. Diagonals are still bisecting each other. In fact, now the diagonals are also perpendicular. Okay, and we know that the diagonals bisect the angles here and here, right? Okay, so now same thing. Pause the video, try those problems. When you're ready, hit play. Okay, so let's take a look at this. We know that MK is 24. So the whole length, MK, is 24, which means each part has to be 12. So I know this has to be 12, this has to be 12. Then JL is 20, which means this has to be 10, this has to be 10. All right, so we know MN is 12, NL is 10. All right, I'm going to erase this for a second so that I can have some space. Let's look at the angles now. We know that angle MJL is 50 degrees. That angle is 50 degrees, which means all 4 of these angles have to be 50 degrees. We also know that diagonals are perpendicular in a rhombus, right? So if one angle is 50, one angle is 90, using my right triangle there, this angle and all the angles along that diagonal have to be 40 as well. So let's answer the questions down here. KNL. So KNL, that's a 90-degree angle. Angle NML, so NML is 40 degrees. And then finally, angle MJK, these 2 angles together makes it 100 degrees. All right, the next problem. We have our diagonals drawn in. We know the diagonals bisect the vertex, or bisect the angles, right? So that means those 2 angles have to be congruent. So that means 13x minus 16 has to be equal to 9x plus 4. Subtract 9x from both sides, I get 4x. Add 16, I get 20. Divide by 4, I get x equals 5. So x is equal to 5 on this one. Okay, next shape is a rectangle. Okay, by definition, a rectangle is that parallelogram again, but it has 4 congruent angles. Now, earlier in the week, we learned that all quadrilaterals have 360 degrees, right? We found that pattern. We came up with that formula of 180 times n minus 2 to get the sum of the interior angles, right? And so we said for quadrilaterals, the sum is 360 degrees. Well, I have to divide that among 4 angles. That gives us 90 degrees per angle. So again, you knew this, right? When you came into geometry, you knew that the 4 angles of a rectangle were 90 degrees. But we're looking at the why of it all. So this is why it all happens. Okay, so again, opposite sides congruent, opposite angles are congruent, and we know that the diagonals bisect each other. But there's more. Okay, so let me draw in some diagonals here. And what we're going to do is we're going to look at something special that happens with these diagonals. So like we did with our alternate interior angles, we are going to look at, not alternate interiors, I'm sorry, like we did our isosceles trapezoids, we're going to look at two overlapping triangles. Okay, so we know opposite sides are congruent, right? And we know our angles. So think about that green triangle. It sits like this. Right now I have these markings on the green one, so the congruent sides, and we know we have a right angle. Then I have this yellow, right? I have this side congruent, and I have a right angle. So these two triangles, these overlapping triangles, are congruent because of side angle side. Okay, now we then prove that the diagonals in this case must also be congruent. Okay, now keep in mind, we said the diagonals have to bisect each other. So if they're the exact same length and they bisect each other, what's actually happening here is that all four of these pieces have to be the exact same length. Okay, now prepare yourself, because here's what else happens. Look at all these triangles that we have right here. Here's 1, 2, 3, 4 isosceles triangles. So these isosceles triangles keep coming back to haunt us, okay? So we have isosceles triangles again. All right, so rectangles give us 4 right angles. The diagonals are congruent and they still bisect each other. And we also know opposite sides are congruent. All right, so take a look at the next set of problems. All right, so on this one, we have a whole lot of angles numbered, but we're only given one angle. All right, so we're given one measurement here. We're given 59 degrees. Okay, so keeping in mind of all those isosceles triangles, right, these are all congruent. So 59 and angle 6 here are base angles of an isosceles triangle. That has to be 59. I also know the 4 corners, the 4 big angles of my triangle all have to be 90. Right? So if I take 90 minus 51, 90 minus 59, I get 31, which means both angle 11 and 5 have to be 31. Okay, now I can solve for angle 9 because I have that isosceles triangle, right? I know this is 59, this is 59. I can solve for this missing angle here. So this has to be 62. I have vertical angles, so there's 62. Keep in mind, we do have parallel lines, right? These are parallel lines. That means angle 11 and angle 4 are alternate interior angles. So this has to be 31. I know this is going to be 59. So this just keeps happening over and over and over again. You keep seeing these numbers. Okay, then when it comes to like 8 and 10, those have to be a linear pair. So 180 minus 62 gives me 118. All right, so if I fill this in, angle 1 is 59, angle 2 is 31, angle 3 is 59, angle 4 is 31, angle 5 is 31, angle 6, I've lost it, here it is, 59, and I forgot to list angle 7. So angle 7 should be equal to 118, angle 8 is 62, 9 is 62, 10 is 118, and 11 is 31. All right, next set of problems. All right, so for this next one here, because this is a parallelogram, we have parallel lines, so those are alternate interior angles, so they have to be equal to each other. So 7x minus 16 has to equal 5x plus 8. Subtract 5x from both sides, I get 2x. Add 16, I get 24. Therefore, x has to equal 12. Okay, for the next one here, keep in mind, you really got to focus kind of on this triangle. It's a right triangle, right? So we know that this is a right angle, which means the two angles that I have expressions for have to be complementary. They have to add up to be 90 degrees. So 5x minus 12 plus 2x minus 3 equals 90. So 7x minus 15 equals 90. Right? Add 15 to both sides, you get 105. So 7x equals 105 divided by 7, and you get x equals 15. All right, our last shape is a square. Now, keep in mind, a square is a rectangle, a square is a rhombus. So it all comes together, right? The square is the parallelogram, the rhombus, and the rectangle all in one. So a lot of stuff happens here, but it's kind of simple too. So let me draw in my diagonals. We still have our right angles, right? Because it's just, it's just like a rectangle. And because it's a parallelogram, we know that opposite sides are congruent. In fact, there's 4 congruent sides. We know we have all of our right angles. We know that the diagonals have to be congruent and they have to bisect each other. We know that the diagonals have to be perpendicular because of the rhombus. We also know that all of these angles are bisected by the diagonals, but we're bisecting 90-degree angles every time, which means all of these angles have to be the same. So all of them are 45 degrees all the way around. That's really about it for the square. Because we did all the hard work for the rhombus and the rectangle, it all comes together in our square. All right, so last set of problems. Take a look at these and then start the video again. Okay, for this problem, it says the perimeter of the square is 92 centimeters. Find the value of x. So if the perimeter is 92 centimeters, that means each side is congruent, right? So 92 divided by 4 gives me 23. That means that 9x plus 5 has to equal 23. So subtract 5 from both sides, I get 18. Divide by 9, I get x equals 2. All right, so the next step is on Friday, we're just going to practice a whole bunch of problems, okay? Because you just really got to start applying all these rules and being able to break down the shapes and figure out what you have and what you don't have. So that'll be what we're doing in class on Friday.